Okay, this is lesson 5.4, part 2, finding angles using the cast rule. We showed the cast rule in part 1, finding ratios. Go over why the cast rule exists and where it comes from really briefly before we look at finding angles. As we've seen, you can draw an angle on the Cartesian plane in any of the 4 quadrants. If you're drawing an angle in the first quadrant, that angle would be somewhere between 0 and 90. If we move into the second quadrant, we'd be between 90 and 180. Into the third quadrant, we'd be between 180 and 270. And into the third quadrant, we'd be angles between 270 and 360. And that'd be rotating forward and not around more than once, just the first rotation. And if we look at it in the first quadrant, we can define sine, cos, and tan in terms of x, y, and r. Because if we think about a point rotating around the Cartesian plane in an angle somewhere between 0 and 360 degrees, we can create a nice right angle triangle with y on the side opposite our angle, x as the adjacent side, and r as the radius of our triangle, or radius of the circle, the hypotenuse of our triangle. And if we think about the signs, the SIGNs of sine, cos, and tan in each of the quadrants, that's where the cast rule comes from. So to review, if we're talking about the first quadrant, x, y, and r would all be positive. So if we had a positive divided by a positive, or y divided by r, we get a positive ratio for sine in the first quadrant. Same as cos, same as tan. Because in quadrant 1, x, y, and r are all positive. So the only way to get a ratio is a positive ratio. In quadrant 2, when we rotate into the second quadrant, the x's in this quadrant are negative. The y's are positive, and the radius is always positive. So we got negative x's. So any ratio that uses an x is going to give you a negative answer. So the two ratios that use x are cos and tan. So in quadrant 2, the only one that comes out positive is sine. And we can use S to designate sine. S comes out positive in quadrant 2. In quadrant 1, all of them were positive. In quadrant 3, negative x and negative y. R would still be positive because the radius of a circle is always positive, but we've traveled down, so negative y, and to the left, negative x. And if we look at our ratios, for sine, we'd have a negative over a positive, which would give us a negative. For cos, we'd have a negative over a positive, which would give us negative. And for tan, we'd have a negative divided by a negative, which is positive. So in quadrant 3, tan is positive. Quadrant 4, only y is negative. Our x is positive because we're on the right side of the Cartesian plane, and our r is also positive. So any ratio that uses a y is going to come out negative, and that would be sine and tan. In this case, cosine would be positive. And this is where our cast rule comes from. Quadrant 4, cosine is positive. Quadrant 1, all are positive. Quadrant 2, sine is positive. Quadrant 3, tan is positive. And if you remember CAST, that will tell you which of the ratios is positive. Why is that important? Well, it's important because if we're asked to solve for an angle, we need to know where those angles could be. For example, if we were finding cosine of an angle equals 0.276, the places where the angle could be would be the quadrants where cosine is positive. And if we go up and look at our cast rule, it's positive in quadrant 1, where they're all positive, and quadrant 4, where cosine is positive. So that means the angle that gives us this ratio would be between 0 and 90 degrees, and there would be a second angle between 270 and 360 that would give us that exact same ratio. So solving these questions, we're looking for both answers. And that's how the cast rule helps us find angles. So we're going to do a couple examples and show you how we find our angles. So let's go back down here. We've got to remember the cast rule. To find an angle, we have to follow 3 steps. Find the reference angle first by using the absolute value of the given trig ratio, which means that when you're given a ratio like 0.276 or negative 2 root 3 over 3 or 0.159 or 5.23, when you find the reference angle, that related acute angle or that beta angle, the way we find it is by taking the absolute value of these ratios. Now you might ask why we're taking the absolute value. Well, we just talked about there's one quadrant where all those ratios would be positive, and that's in quadrant 1. And in quadrant 1, if you find the angle answer in quadrant 1, you've also found the related acute angle beta. Theta and beta are the same in quadrant 1. So if we use positive ratios, we're going to find beta for all of these ratios, and then we can use beta and the knowledge of what quadrant our angles are in, our answers are in, to find our answers. And I'm going to show you what that looks like. Let's do the first example. It says cos of alpha. I'm going to change it to theta just to keep our notation the same. It really doesn't matter, but let's make all these thetas and we can talk about thetas and betas. Determine all possible angles to the nearest degree within 0 to 360, that means one turn on the Cartesian plane in the positive direction, associated with each of the following trig ratios. Cos theta is 0.276. Let's first find beta. And the way we find beta is we take the absolute value. We have a positive, so that's good. To find beta, we do cos inverse. And if this number was negative, we would make it positive so we could find our beta. And if we do cos inverse, second cos, 0.276, we get 73.9, and we're looking for angles to the nearest degree, so I'm going to round that to the nearest degree, 74 degrees. 74 degrees is not necessarily the answer. 74 degrees is the related acute angle. It's the beta, it's not a theta. This is the reference angle that's going to lead us to our answers. And second step is determine which quadrants our answers might be in. Well, our answers would be where cosine gives us a positive ratio. So let's go look at our graph. Cosine gives us a positive ratio in quadrant 1 and quadrant 4 because of the cast rule. Now, you're not going to have that big table when you do one of these questions, but what you will have is a Cartesian plane that looks like this. And if it's not given to you, you'll draw it. And if you label C, A, S, T on the quadrants, it'll help you remember which one cosine's positive in. Cosine's positive where all are positive and where cosine is positive. So in quadrants 1 and quadrant 4. So up here I'm just going to write cos is positive in quadrant 1 or quadrant 4. Now you don't have to write that on your test. You could designate it by like boxing the A and the C or some way that shows you where your answers are going to be. Now, how do we get the answers? Well, the way you get the answers is you graph this related acute angle in both of these quadrants. So that would look like this. And like this. And the answers are the angle from standard position. So back to our standard position, our initial arm, and rotate to the first terminal arm would be right here. So the first answer is 74 degrees. Now remember, in quadrant 1, theta and beta are equal. So if we're solving for our angle in quadrant 1, the beta you found is your first answer. To find our answer that's in quadrant 4, our second theta, we would start at the initial arm and we would have to rotate all the way around into quadrant 4. That would be our second theta. Our first theta was right there. So our second theta would be into quadrant 4. It would be 360 degrees if it went all the way around, but we fell up 74 short. So theta 2 is 360 degrees minus 74 degrees, which is 286 degrees. So there's our first angle, sorry, our second angle, and there's our first angle. Those are our two answers. Let's try B. B says cosecant theta equals negative 2 root 3 over 3. Well, same first steps. We're going to find beta. Now we're working with cosecant. Cosecant is the reciprocal of sine. So we can say that sine theta is equal to the reciprocal of 3 over 2 root 3. And you might recognize that as a special triangle ratio, but if you don't, it's okay. The second step, or the continuation of the first step, is to find the absolute value, or so find the reference angle using the absolute value. So we're ignoring the negative to find beta. Beta would be sine inverse of 3 over 2 root 3. And I recognize that as a special triangle angle. I'll show you on the calculator that it does still work even if it's a special triangle angle. 3 over 2 root 3. Excuse me. 60 degrees. All right, so now we know our reference angle is 60 degrees. Now we have to think about what quadrants it's in. Well, when we flipped it and did the reciprocal, we're talking about sine. Sine is negative. So I'm going to draw my Cartesian plane. C-A-S-T. Well, where is sine negative? Well, sine's positive in S and A. So that means it's negative in T and C. Sine negative in 3 and 4. So we're going to draw our reference angles, our related acute angles, in quadrants 3 and quadrant 4. 60 degrees, 60 degrees. And now to find our answers, we start from standard position and we rotate to our terminal arm. So our first theta is in quadrant 3, and our second would be in quadrant 4. So let's do a little bit of math. To find our first answer, we're going 180 degrees plus 60 more. So it would be 180 plus 60 is 240. And our second angle would be into the third quadrant, 360 degrees, but we fill up 60 degrees short. So it's 360 minus 60, which is 300 degrees. And there's our second answer. Our two answers are 240 and 300. And in fact, if you check that on your calculator, we could have checked the first one too, we should get the right ratio. So let's check it. Sine 240 is root 3 over 2. Now I said that I recognized this from the beginning, and I did recognize it. If I do a little bit of math up here, negative 3 over 2 root 3. Well, 3 is just root 3 times root 3. And now we have root 3's on top and bottom, so we can divide them away, and that's where we end up with our negative root 3 over 2. And if you think about your 30, 60, 90 special triangle, root 3 and 2 are two sides. And if we look at which angle, root 3 would be the opposite and 2 would be the hypotenuse, it would be the 60-degree angle. That's how I knew the answer was going to be 60. But if we go check our calculator here, sine of 240 is root 3 over 2, and it's negative. That's the key. So we're looking for the one that gives us our negative answer, and it is, in fact, 240 and 300. Negative root 3 over 2. So those are the two that give us the right angle. Now, If we'd used the reference angle and put them in quadrant 1 and quadrant 2, we would have got angles of 60 degrees and 120 degrees. And look what happens if you do sine of 60. You get root 3 over 2. And sine of 120. You get root 3 over 2. You get the exact same ratio, just with the opposite sign. And that's the key to this entire unit, is if you can start to recognize that there are 4 different angles that give you the same ratio. 2 of them will give you the positive ratio, and 2 of them will give you the negative ratio. And figuring out which quadrants are going to give you the positive ones and which quadrants are going to give you the negative ones is the key to solving these questions. So with that in mind, there are 2 more examples, C and D. Give those a shot, and you can check your answers on the course website. Thanks for watching, and I'll see you next time.